our whole goal in solving systems of equations is to find the ordered pair, to find the point where the two lines intersect. The first method that we learned was actually physically graphing both lines and finding visually by looking at where the point was that the two lines crossed. So we practiced that in many ways, but we already should know that that's not the most effective way or efficient way, because you either need graph paper and a ruler, and you have to make the most perfect lines possible to find the actual point that they intersect, or you need a graphing calculator, which does it perfectly for you, and not all the time will you have those things in front of you. The only thing that you need to solve the systems with this method is like a piece of paper and something to write with. You can't do this in your head, but you can do everything with algebra, with numbers and variables, and you won't need any aid with any type of resource like a graphing calculator or a ruler or anything like that. So here are the 4 steps that you have to follow to solve systems by substitution. The word substitution in math is going to mean anything that's equal to each other can be replaced in for each other. So in step 1 of the equations has to be set up so that it says y equals or x equals. Yesterday, every single equation that we saw had one equation that was set up like that. Today, we're not going to see that. So I'll explain when we get there that that's the difference today. That's why it's more difficult today. Step 2, you're going to substitute the expression in for the other equation and solve for that variable. And step 4, after you solve for one variable, you solve for the other variable, and you get 2 answers. Each problem is difficult because not only do you need one answer, but you're going to get 2 answers. Every problem has 2 numbers as the answer because each answer is an ordered pair, which is in x, y form. So you will have 2 answers per problem. So yesterday we solved these examples in example 1, 1, 2, 3 on page 9. And then we also did some practice problems as well. But I purposely skipped number 2 here and number 5 here. So what we're going to do on page 10 is complete numbers 2 and 5. So hopefully you have some space to do that. I know that each problem does require a ton of space. So try and squeeze it in if you don't have enough space, or use a separate page somewhere for numbers 2 and 5. In order to use substitution, the first thing that has to happen is one of the equations has to be solved for a variable. Number 2's equations say y minus 4x equals negative 6 and 4x plus 2y equals 12. Neither one of those equations looks something like this. In number 3, see how it says x equals? In number 4, see how it says y equals? In number 1, see how it says y equals? All of these problems were ready for the substitution step because one of the equations said either y equals or x equals automatically. Number 2 does not look like that. Number 2 says y minus 4x equals negative 6 and 4x plus 2y equals 12. So the first step that we actually have to take before we can do substitution is we pick one of the 4 variables. Each problem is going to have 4 variables to choose from. 2 x's and 2 y's. An x and y in the first equation and an x and y in the second equation. You want to choose one of them. You can choose any of them. It doesn't really actually matter. But you want to choose the one that is the easiest, so it requires the least amount of work so that there's really not that many options for mistakes. So look at the 4 variables. This y, this is 1y, this is negative 4x, this is positive 4x, this is positive 2y. Take like 10 seconds and look closely at these 4 options and try and decide which one looks the easiest to solve for. Meaning, which one could I easily just say, okay, I can take this equation and solve this one for x, or I can take this equation and solve this one for y. So take like 10 seconds to just look at it. Now, your whole goal is to make it as easy as possible, meaning that you might have to move something to the other side by adding or subtracting, but you never want to have to do that and then do something else. Which one looks like it's the easiest one to solve for? Bailey?
I was thinking the top one.
Yep. Which variable?
Oh, well, you can put the y, if you add the 4x to both sides,
Yes.
then it becomes, then you already have your equation.
Yes.
Y equals.
I agree completely. So what Bailey is saying is take the first equation and you can easily solve that thing for y. And I agree. That is the easiest variable to solve for out of the 4 options, because the only thing you have to do to solve this for y is move the negative but you then also would have to divide by the number in front of it. So like this is a negative 4x, so in the end you'd have to divide by negative 4. You'd have to divide this one by positive 4 in the end. You'd have to divide this one by positive 2 in the end. So for this one, all you have to do is add 4x to both sides, and you have the equation solved for y, and it's y equals 4x minus 6. Now that is only the first step of the substitution process. What we did was we took the first equation and we rewrote it so that it says y equals. But it's really important to realize that this equation right here, this first one, and this one right here, these are equal equations. They're the same exact thing. There's no difference in that line that represents those equations. One equation's in slope-intercept form. The one you just solved for y is in slope-intercept form. This one's not. It's just not in slope-intercept form, but it's the same numbers. Things are just moved around differently in different spots. So now we are ready for substitution. What we did was just prepare for substitution. What we have to do is take the other equation that was not used, this 4x plus 2y equals 12 equation, and we now have to substitute 4x minus 6 in for y, since that's what we just solved for, and that's what we can now use the substitution step for. Substitution says you can replace things that are equal to each other in for each other at different times, like a substitute teacher comes in and out for teachers as they need to be out of school for the day. So what we will do is replace that y, this y right here, with what it's equal to, which is 4x minus 6. So it will look like this, 4x plus 2 times, in parentheses, 4x minus 6 equals 12. You have to use parentheses when you're substituting the numbers in because this is 2 times whatever y is. And since y is the whole thing, 4x minus 6, you need parentheses to show that it's 2 times that entire thing. Okay. Now that you completed the substitution step, now you should see only the same type of variable. I see an x here and an x here. That means that I can now solve this equation. Whenever you have parentheses and you have a number in front of those parentheses, the only way you can get rid of them is through using the distributive property and multiplying everything on the inside by the number on the outside. So what this will turn into is 4x plus 2 times 4x is 8x. Minus 2 times 6 is 12. So now our equation looks like this. We don't have any more parentheses. Now we just have to continue on solving. We have 4x plus 8x minus 12 equals 12. What's the next thing I could do? Jessica?
Add like terms.
Yeah, perfect. Like terms. The 4x and the 8x can combine together to be how many x's? 12x. Perfect. There's a lot of 12s in this problem. 12x minus 12 equals 12. Now we're going to solve this equation. We want to undo the subtraction first to move that number to the other side. So to cancel out minus 12, we would add 12. And we get 12x equals 24. And then what's the last step in solving this? Addison?
You divide 12 by 24.
Yeah. And we're going to get x is equal to what?
2.
2. So that means half of our equation is done, or half of our process is done. We now know that for this ordered pair, it has 2 as the x value. But unfortunately, we're not done. We're like more than halfway done, though, because now that we have one of the answers, finding the other one only takes a couple seconds. This process takes the longest. This involves all of the variables and all of the tricky algebra. Now we have a real number as our answer. As soon as you have a number as your answer, things are just like mathematically just calculating things to see what the answer actually is. What you can do now is choose from all of the other options if you want. You have this equation you can use, and you can put in a 2 for this x. You have this equation you can use. You can put a 2 in for that x. Or I think you should use this one, because this one is already solved for y. So you can just quickly figure out what y is by taking 4, multiplying it by 2, and then subtracting 6, and you have what y is equal to. What I did was I took the equation y equals 4x minus 6, and I replaced the 2 in for x, since that's what we found x to be equal to. And I'm going to get what for y? 4 times 2 is 8. 8 minus 6 is going to be also 2 here. So all together, we have x is equal to 2. Y is equal to 2. Our final solution will always be an ordered pair. Our ordered pair answer is 2, 2. That means that these two lines, if I were to graph them on the same exact coordinate plane, they would cross at the point 2, 2. How could I verify that I did not make a mistake? What can I do with my answer to just double check to make sure it's true? I mean, there's more than one answer to this question. Jessica, what's one way?
Put the x and y
Yes.
into the equation.
Yeah, so you can take the original equations, and I know it just takes time, but you'll verify it's right. And you can put 2 in for y and 2 in for x and make sure that it's equal to what it should be equal to. 2 minus 8 is negative 6. It works. 4 times 2 plus 2 times 2. Let's see if that equals 12. 4 times 2 is 8. 2 times 2 is 4. 8 plus 4 is 12. Yes, it works. You could also use your graphing calculator, but in order to do that, all of the equations have to be in slope-intercept form because your calculator only understands y equals. So you'd have to do some algebra to put the second one into slope-intercept form. So that's the process. It takes a lot of time. It's definitely time-consuming and tedious. And if you make one little tiny mistake, it'll mess up everything. So you really do have to take your time with it and make sure that you're checking each step before moving on to the next one. Number 5 was another problem that we skipped yesterday because we were not ready for this next step, which is take the equations first, pick the one that's easiest to solve for, and solve for that equation or for that variable. So looking at the 4 options, we have this x, this y, this x, this y. You always want to make it as easy as possible on yourself. Sometimes it's not. Sometimes all the options are kind of bad options. But in number 5 here, one of these variables is way easier to solve for than the rest. Which one is the easiest to solve for? Morgan?
The y in the top.
Yes. This y in the top equation is the easiest to solve for because it's just one y. All you have to do is move the 2x to the other side, and you have y is equal to negative 2x minus 9. So I didn't show the work here, but what I did is I just subtracted both sides by 2x, and I got y equals negative 2x minus 9. That's the same thing as this equation right here. I just moved the 2x to the other side by subtracting it. So now I have one of the equations equal to a variable. Substitution says, okay, use the other equation that was not used yet, the 6x minus 5y equals negative 19, and use substitution and replace in negative 2x minus 9 in for that y variable. This one's really tricky because there's a lot of negatives. So here's what this will look like. 6x minus 5, parenthesis, negative 2x minus 9 equals negative 19. Lots of negatives in this one. We have to be very careful.
Can you check my answer?
Yeah, well, we're going to go through it right now. So, yep.
Negative plus negative equals positive, right?
Times. Yes. So we have to be really careful when we are multiplying numbers, especially with identifying what type of number it is that we are multiplying. So what I mean by that is when I use the distributive property, I know I have to multiply the number on the outside by the numbers on the inside, but you have to know that the number you're multiplying is actually a negative 5. That minus sign is attached to the 5. So when you go to use the distributive property, this 6x is not really worried about, just write that. You're going to be multiplying a negative 5 times a negative 2x, so it's going to be a positive 10x. And you're going to be multiplying a negative 5 times a negative 9, that's a positive 45, equals negative 19. The reason that I got that was because you have to multiply negative 5 times the numbers on the inside. But after you did that, what was nice about it is everything ended up turning positive, except the negative 19. So now it's time to combine like terms. We can combine 6x with 10x. That's going to be 16x. We have 16x plus 45 equals negative 19. The next step in solving two-step equations is to move the plus 45 to the other side by subtracting it. So we put minus 45 here and here. We get 16x equals negative 64. And the last thing we would do is get rid of the 16 by dividing it. And what's negative 64 divided by 16?
-4.
Perfect. Okay, so we have our x answer. X is equal to -4. Half of our answer is done. Our ordered pair is going to be at -4, comma. We just have to find the y value. To find the y value, you're going to want to try and just find the easiest equation to use. You can use any of them, though. You could use any of the beginning two, or the easiest one, I think, is going to be the one that's already solved for y, which is this one right here. We found that -4 is what x is equal to, so I can find y by replacing -4 in for x. And then solving for y, I should have it in a couple seconds. -2 times -4 is +8. What do I get as my y coordinate? Perfect. So we get my final answer, the solution altogether is -4, -1. So this process just requires a little bit more time because you have to take the first step, which is deciding which variable to solve for in order to solve these problems. What we're going to do now is practice these problems with some practice in the packet. You're going to skip this next page, these pages that say 5.2 exercises. We're going to skip this whole page front and back. And we're just going to move to just some skill-based questions that look just like the ones you just were working on. We're not going to have time to do all of these today. Let's just focus on a couple. Let's do numbers for now. Let's do 3 right now and see how long that takes. Let's try number 1 right now, number 8, and number 9 right now. So go ahead and try 1, 8, and 9. I might give you, these take a long time, so I might give you, honestly, like 10 minutes, maybe 8 minutes. See how far we get. Number 1, just make sure you're checking. Is it ready for substitution? Some of them are easier than others. If it already starts with y equals or x equals, you don't have to solve for anything. You can just get started with substitution. But then as you look at number 8 and 9, you have to pick which variable to solve for first, and then you have to use substitution.